Hello, welcome to the lecture 1 of Unit 3. Part 1 is more object-oriented programming. And as from what we've seen before, we create objects when we write programs. They're contained in a class, and we can change the behavior and the characteristics of the objects through another class that we typically call the runner. We've seen some examples of object instantiation. We've created scanners to go into our programs, right? And we can create all sorts of objects, right? As long as we have a class that defines how they behave. And when we do that, we create a reference, right? So the monster here would have a reference called Chuck, and that reference would give the address of where the information about that monster is stored in memory. And what we saw near the end of class last time were constructors. These are the bits of code that construct the actual objects. Our objects are going to have instance variables, integers and doubles and such that are associated with it. They give the properties. The constructor is what creates a place for that. Now in the code they look like methods, right? They will have the same name as the class, but they have no return type. Now we've seen methods that have the word void in them. They don't have that extra word in them. We'll talk about why in a minute. Okay. What they do is initialize all the instance variables for our object. As an example, we'll go to triangle runner in the demo code. So we have the triangle class, and the void main is in the triangle runner. And we created a couple of triangles in here. The first one, try1, creates a triangle and has no parameters. That's okay. In the triangle class, if we give it no parameters, what it does is automatically call the method called setSides, and it makes all the sides equal to 0. A is going to be 0, side A, side B, side C will all be 0 automatically. What they call that is the default constructor. If you have a constructor, if you're calling a new object and there's no parameters, the constructor with no parameters is the default constructor. So you'll have something inside here that gives values to in this case, the 3 sides, but you don't have any control over them. It's built into the program. A little bit later on, we do something different. We have a different kind of constructor where we actually specify the lengths of the 3 sides, 5, 6, and 7. So there are 3 parameters in there. In order to do that, you just build a second constructor. The default contains no parameters, so we'll take no information. But if you give a new triangle constructor with 3 parameters, it knows to look for one that has 3 parameters. And we'll set sides A, B, and C to whatever values you give it. In this case, 5, 6, and 7. Now they both run just fine. When you ask for a new triangle with no parameters, it knows to use the default. When you ask for a triangle with 3 parameters, it knows to use the other version, which is called the initialization constructor. It allows you to initialize the 3 sides on your own. Okay? And it will take whatever values you're using as parameters. So, as it says, the parameters allow data to be passed into the class so it can be assigned to instance variables so that you can decide what values to give it. And when you run it, you'll see that they both come up. The first triangle uses the default constructor and therefore has the sides 0, 0, 0. The set sides method is how we can change the length of those sides. Changes to 4, 4, 4. And last but not least, we create the second triangle with sides 5, 6, and 7. It uses the correct constructor and saves those values as 5, 6, and 7. So you can have more than one constructor of an object. You can build it more than one way. The program knows to look for the ones that has the same number of parameters that you give it. If I don't give it any, it knows to use this. If I give it 3, it knows to use this. If you use something different with just one parameter or 2, there is no constructor for that, you'll get an error message. So it does have to match some option in the actual class. It does have to match the number of parameters, the constructors that you have available. So when you give it 3 values, it takes those in as parameters and does what you ask to it. One thing worth mentioning, methods such as set sides again has this extra word void in it. We'll see later on what that word means in particular, but know that public void and then a name is a method, public and then the word that is the same as the name of the class, those are constructors. They always have to have the same name as the class they're in. In the class triangle, you can only create triangle objects. Now the variables we put in there have what's called scope. There are times when they exist in the program and times when they don't exist in the program, and that is called the scope of the variable. So any variable you write in a class is defined inside some set of braces, and they will only exist while the program is inside those 2 braces. So this integer fun will only exist when you're at the point in the program that's between those 2 braces. Side A, side B, and side C are at the top of the program, so they exist throughout the entire class. The brace here that starts and the brace here that ends. So you can use them anywhere in the class, in all the methods, in the constructor. As long as they're at the top level of brace, they are throughout the class. So the scope of an instance variable is the entire class where that variable is defined, since it is at the top level of brace, the very first brace in the class. In the program instancevars.java, you have 3 different instance variables, and again their scope is the entire class because they're at the top. So 1, 2 in total I can use here in the program, I can use here in the program. As long as they're at the top, they will exist throughout the entire class. So even though I'm calling the add method down here and the print method down here, 1, 2, and answer are at the top of the class, so they are accessible throughout the entire class. And you've actually seen this run before. We ran it last time in class. When I call the add method, I get an answer that is 8 plus 3, so it prints the value 11 when I print the answer. Now, just to be clear, when you initially create a variable, that is defining it. That's when you're telling the computer, I'm going to need space for this integer, and give it the name num. Assignment is when you give it an actual value. Now, we did see before that if I don't give it a value, it'll get the value 0 by default. When I assign it a value, I can give it whatever I want. as long as it's appropriate for an integer. So here, I've defined the variable. I've just saved a space in memory, put a space of memory inside. Here, I've defined it and assigned it, versus just assigning it where I'm giving it a value. If you're going to do this, you have to have previously defined the variable somewhere. So as long as you've defined the variable somewhere, you can reassign new values to it anywhere in the program. Just be careful. Don't use int a second time. Once you define it, after that you only use the name. If you use int twice, you'll get an error statement. It's trying to create a new num, even though you've already got one. Local variables are ones that only exist in small pieces of code. So a subset of the entire class. So for example, this instance variable fun, whenever we create the local vars object, this instance variable of fun exists everywhere throughout the class. However, there's another one in here, another integer called fun, that is within this method change. So this variable actually only exists for as long as this method is running. So when this method starts, I create this local variable. But when the method ends, it disappears. This one up here is still fine since it's outside those braces. But wherever the braces begin and end for that variable, that's where the variable begins and ends. So as a bit of explanation, we create this test, and we call the method change. While this method is running, we have this local variable equal to 99. But once it's done, it ceases to exist. We go back to the original variable value of fun, which is by default 0, and that's what actually gets printed. So as evidence of that, so it looks like we changed the value of fun to 99, but this is a different fun. Right? This variable up here is the variable that exists throughout the class, the instance variable. This local variable disappears once the change method is done. So that 99 doesn't stick. Right? The original value of 0 is what gets printed because we're outside the method change. So the local variable disappears, but the instance variable remains to be printed in the print method. So again, another demonstration. You get the output of 0 because this is the fun that gets printed and not the local variable. Another way of looking at it, we create this object, right, of the type local vars. The instance variable exists everywhere throughout that object. So wherever we are with local vars, the fun has a value of 0. If we're inside this method, we have the value 99. But when we're printing it, we're not in this method. We're in the print method where we go back to the value of 0. So we have this instance variable has scope everywhere throughout the object. This local variable has scope only within the method where it's called, only within those braces. So now, take a few minutes. This is the end of the lecture 1. Take a few minutes with the Check for Understanding worksheet. It's an example of some methods being called with values being passed, and see if the information makes sense. If not, bring questions to class next time. After you're done with that, go to part 2. In the next video, we'll talk about some built-in math in Java.